Alright, so our first notes is 1.2 arithmetic sequences. These are our first notes that are for our actual content that you'll be learning. So first, let's do some definitions. So an arithmetic sequence is a pattern of adding or subtracting the same number to each term. Okay? A common difference is the number we add or subtract by in an arithmetic sequence. So both of these need to get written down in your notebook. Again, this is a video, so I'll go a little bit faster than I normally do in class. But remember, it's a video. You can pause, you can rewind. Alright, so after that, we have this image. So at the beginning, we have 1 circle. At 1 month, we have 3 circles. At 2 months, we have 1, 2, 3, 4, 5 circles. At 3 months, we have 7 circles. Now, the first thing that we're going to do is write this in what we call function notation, because that's what we are going to be using a lot of in this unit. So at the beginning, right? So if this is 1 month, at the beginning is times 0. So we would write this as f of 0 equals 1. Okay, and I'm going to write a little love note, and you can write it too. But what I'm going to put here is this 0 means beginning, and then this 1 represents the number of circles. Okay? Then for 1 month, we have f of 1 equals 3. Once again, this 1 stands for number of months. So this is 1 month. And then this 3 here is the number of circles. All right. So at 2 months, we have f of 2 equals 5. And that's how we say that. If I didn't say that earlier, f of 2 equals 5. When you see f with a parentheses like this, we say f of 2. Okay. Next up, we would have, for this last one, we'd have f of 3 equals 7. And again, all of this is function notation. Okay? So let's do an actual example of where I show you where arithmetic occurs. And again, it's using this image above. So what I'm going to do is I'm going to make a table that's going to look like this. So at times 0, we have 1. At 1, we have 3. At 2 months, we have 5. At 3 months, we have 7 circles. So that's where all of this information comes from. So we just wrote it in a table from this image up here. So this n that we have is going to mean the number of months. And then this f of n is going to mean the number of circles. Because this is algebra, we're not going to write number of months and number of circles anymore. And if you didn't know this, the hashtag sign means number in math. So the next thing we're going to do here is figure out what our arithmetic or what our common difference is, right? And again, the common difference is what are we adding or subtracting by as we go down this table. So what number can I add by to get to 3? That's the same that I would get when I add 3 to get to 5. Okay, it has to be the same or else it's not going to work. And in this case, we're adding by 2's down the table, and you have to add by the same number or subtract. I know I'm adding because I'm getting bigger. So next up, I'm going to write how we get from one number to the next in function notation. So if I start with 3, right, if I want to get to 3, then I have to take the number 1 and add 2, right? So to get my next number, I took my previous number and added 2. Now, I'm going to write this in function notation because that's what we're focused about. So 3 in function notation is f of 1. And then 1 in function notation is f of 0. So same thing, these two things mean the same thing. One's written with just numbers, the other down here is written in function notation. So let's look at this guy. Now to get to 5. So if I wanted to get to 5, I would have to take 5 equals to 3 plus 2. So to get my next number, we took a previous number and added 2. And we wrote it in function notation. So 5 turns into f of 2, and I get that information from right here. And then 3 turns into f of 1, because again, I get that information from right here. I'm writing it in function notation, plus 2. All right. So if I wanted to get 7, I would have to take 7 equals 5 plus 2. And again, I'm writing this in function notation down here. So 7 would be written as f of 3. 5 would get written as f of 2. And then we added 2. Okay? That common difference doesn't go away. It's always the same. So when we write this in basic, like we don't know any numbers, we write it as f of n is equal to f of n plus 2. Okay? So again, this means right here, to get our next number, we take our previous number and add the common difference. Okay? We also, in arithmetic, or I'm sorry, not in arithmetic, but in this type of formula, we have to give the start of our table. And I got that information from right here. F of 0 equals 1. F of 0 equals 1. Now this thing that we just wrote out, this is called the recursive equation or the recursive formula. It's very common. We see it a lot. A lot. Like a lot. So let's do a couple examples. So if I have 0, 1, 2, and then I have 100, 150, 200, what's my common difference? Well, I'm increasing by 50, so I'm adding by 50 all the way down. So when I write this recursive, I'd write it as f of n equals f of n minus 1 plus 50, and then given f of 0 equals 100. Now, here's something that's super important. This f of n equals f of n minus 1 is going to be the same in any recursive. That doesn't go away. What changes is your common differences and the start of your table. So this start of the table is f of 0 equals 100. I got that because f of 0, we started at 0, equaled 100 over here. Then we have our next example. We have 0, 1, 2, 20, 18, 16. This table is going down by 2s. It's subtracting by 2. So when I write the recursive once again, no matter what, it's always going to start with f of n equals f of n minus 1 minus 2. Or in this case, I decided to use x's. It doesn't matter what letter you use, as long as it repeats that pattern of f of a variable equals f of a variable minus 1, and then the common difference was minus 2, that's what we did here. And then the start of our table we have to write out, which is 0, 20, so we write it as f of 0 equals 20. Okay, again, this is all just, we're taking this table, writing that information out as a recursive and function notation, because that's the thing that we're working with, is function notations. So in our next table, we have 0, negative 5, 1, 0, 2, 5. So my table here is increasing, and it's increasing by 5s. So when I write my recursive, I write it as f of n equals f of n minus 1, that doesn't go away, plus 5. And then we start with 0 and negative 5, so when we write that as a function, we write it as f of 0 equals negative 5. All right, so flipping over, now what we're going to do is we're going to expand and simplify our table. So this is new stuff. Okay, so now for example 5, we're going to write a expanded table. So we're going to have an n column, an f of n column, an expanded column, and a simplified column. And we're going to have 0, 1, 2, 3, because that's how we're usually going to start, is with the 0 for right now. Just know that's going to change. And for my first example, let's have 1, 3, 5, 7. Okay? So if I'm going to expand this, I always just bring over the first number here. So this first number here is 1, so I'm going to just bring it over. Ain't nothing hunky-dory crazy about this. I just brought it over. But now, to get to 3, I did 1 plus 2, right? Because our common difference in this guy as we go down is adding by 2. So I have 1 plus 2. Now in the next bit, I'm going to have 1 plus 2 plus 2. Why do I have 1 plus 2 plus 2? Why don't I write just 1 plus 4? Because starting from this number 1 up here, we added 2 and added 2 again. So that's why we have 1 plus 2 plus 2. Which means for this last one, we're going to have 1 plus 2 plus 2 plus 2, because we started from 1 and added 2 3 times. That is always how our expanded works. We bring over our first number and then keep going down our table of how much we added our common difference by. Now in this case, our common difference is 2. When we simplify, I always start at the bottom because that's just how I roll. And I don't want to write plus 2 that many times anymore. I'm lazy, and the further I get down my table, that's more plus 2's I got to write. So what we're going to do instead is we're going to write 1 plus 2 times 3. Miss Rawolf, where did you get this 1 plus 2 times 3? Well, I added 2 3 times. I can shorten that as 2 times 3, because 2 plus 2 plus 2 is 6, and so is 2 times 3. That's also 6. Whenever you want to shorten, adding a bunch of stuff of the same number a lot, you can shorten it to multiplication. So the next one here, we added 2 twice, so we're going to have 1 plus 2 times 2. And the next one here, we added 2 once, so we do 1 plus 2 times 1. This last one's a little bit crazy, but we didn't add any 2's, so we do 1 plus 2 times 0. Now, we can write this as an equation. We can say it's f of n equals 1 plus 2 times some number. But that is not mathy enough, this phrase, some number, right? We got to give it a letter, because it keeps changing down my table, this some number. The 1 plus 2 part doesn't. That's staying the same. And so it stays the same in this particular equation. So what we're going to do is we're going to call this the explicit equation. And instead of some number, we're going to write an n. So the explicit equation for this guy is f of n equals 1 plus 2 times n. And again, this always starts with f of n equals. The recursive starts with f of n equals f of n minus 1. So looking at our table here, we're going to write another one out, but this time it's going to be 100, 150, 200. When we expand it, we know we're adding by 50, so we start with 100 and bring it over. Then we did 100 plus 50, because that's how we get from 100 to 150. And then we have 100 plus 50 plus 50, because that's how we get from 100 all the way down to 200. And then we're going to simplify. And again, I always like to start at the bottom. So in this case, we had 50 twice, so we do 100 times 50. 100 plus 50 times 2. We added 50 once here, so we'll have 100 plus 50 times 1. We added no 50s here, so we'll do 100 plus 50 times 0. The explicit for this guy is going to be f of n equals 100, because that is always in there, plus 50. That is always here in my simplified. What changes is what I multiply by the 50, so that's where I'm going to put my n. Okay? Now let's say we have tables with x's, and that's okay, we can have that. So what we're going to do is we'll have 20, 18, 16, which means we're subtracting 2. So I'm going to start with that 20 and bring it over. Then I did 20 minus 2 to get 18. Then I did 20 minus 2 minus 2 to get down here to 16. I'm going to simplify this, and I always like to start from the bottom. So I had 20 minus 2 times 2, because I subtracted 2 twice. 20 minus 2 times 1, because I subtracted 2 once. 20 minus 2 times 0, because I subtracted 2 no times. So when I write my explicit out, it's going to be f of x, because this is an x here, and this is an x here and here. And therefore, I have 20 minus 2, that's always there in my simplified. But the thing that changes is my number in the back, so that's going to be my x. If it always changes, that means we don't know what it's going to be at some random time. So looking at the next one here, we have -5, 0, 5. So we're adding by 5s down our table. So we start with -5, then -5 plus 5, then -5 plus 5 plus 5. So when we simplify this, we should have -5 plus 5 times 2, because we added 5 twice, and then -5 plus 5 times 1, because we added 5 once, and then we have -5 plus 5 times 0, because we didn't add any 5s here. There's no 5s being added. Now again, when we write our explicit, we look at what's the same within our simplified. That's -5 plus 5, and then what changes is this back number. So when I write my explicit, I'm going to have f of this time we're using a's. I'm going to have f of a equals -5 plus 5, because that stays the same in my simplified. But my a will be my variable, because that is what's changing. Okay, and that's because that's the a that we used. All right. Homework is 1.2 day 1, arithmetic sequences. It's a half sheet. Thank you for watching this. Make sure this is written, because I do take down points for the notes at the end of each unit. Have a good one.